our SGA, we got multiple components in SGA. Set of background processes, 5 main: DB writer, log writer, checkpoint, SMON, PMON, and then we were talking about the files. So we got one of the file here. Data files, redo log, and a control file. And yesterday we were talking about when a connection is established, a process is running on the server process. On the client side, we got a process called as a user process. A connection, we got server process. On the client side, we got a user process. Server process will go through 3 stages. What are those? Parse, execution, plan, and a fetch operation. 3 stages. Now let's understand there is a SQL prompt, a connection established, and what is the query. Yesterday we discussed about a query, right? A select query, how it is actually running. Let me take the same query. Let's say select some columns like EMP number, name, comma job, comma salary, comma department number. Correct? From EMP, is the query done? No. I am going to write where EMP number equal to 101. Employee number or employee ID equal to 101. Let's say this is the query submitted. When you submit the query, user process hands over this to the server process. Server process will do first what? Parsing of the statement. In the parsing, what? Your syntactical checks, select from where, verified, columns and everything done. Then semantic checks, your table exists or not, columns, do we have these columns with the same name or not, the user, the permissions, correct? All these checks are done. We call it as a semantic check, syntactical checks, and the second one is a semantic checks, right? Okay. Syntactical and semantic checks. Once the parsing is over, completed, the user is a right user and the table exists, column exists. User also have permissions to access. Once everything is done, then it will go to the next stage. Then it will go to the next stage. Next stage is what? Execution plan. Now, what is this execution plan here? Before we start with execution plan, there are a few more things. Let's try to understand. Right? There are a few more things. Let's understand. What is that? These are all files. Where they are actually stored? These are all files, data files. All your files, where they are stored actually? Where they are stored? Disk. On a disk. Disk. On a storage, on a disk, on your hard disk. Correct? Yeah. So on your hard disk, they are stored. Have you seen the hard disk anytime? How it is? A USB hard disk you would have seen, right? We carry it every time. I'm not talking about that. I'm talking about the inside the hard disk, how it is. Yeah, how it is going to be hard disk. So I was talking about the hard disk. Hard disk, okay, you've seen that USB hard disk, but this is another one actually, hard disk, right? Normally, a bigger hard disk we see in our servers or even desktops. We call it as a 3.5 inch hard disk, 3.5 inch, right? The other one is a 2.5 inch. The smaller hard disk we get, external hard disk, they are 2.5 inch. Right? Understand, please. Now I'm talking about the inside part. Not this is also not inside. I'm going to ask my people today to just get it, take it to technician and get it open. I want to show inside how it is actually where your data writes. Right? You can Google that. For online people, I can show it on the browser. Right? For offline, it is difficult at this moment. But anyhow, you can. Sorry.
Inside it is a magnetic media.
Yeah, it is a steel magnetic. It's a steel magnetic plate, a round circle plate, a steel magnetic plate on which your data will be stored. Correct? Now, why we are talking all this? Let me spend some time here on that. Right? Okay, so I'm talking about a steel magnetic plate on which your data is stored. Correct? Yeah. Wrong. Now again, right, this disk will be actually rotating round, and there will be a handle kind of thing, a handle, and there will be a header pointer on that, which will be moving up and down on this. This won't move. Only the disk will rotate and the pointer will move up and down. So data is written on this one like this. Correct? So the disk will rotate and the pointer will move and it will do an IO. IO operation. IO means input, output, or read and write. I'm reading data or writing data. Correct? IOs will happen on this. On the disk level again, right? You can Google that, man, about the hard disk functioning. You can see so many nice videos, just couple of minutes videos, you can understand. So we are talking about a hard disk, and data is stored on this in the form, the smallest unit on the hard disk is the sector, right? What are these? These are called as tracks. These are called tracks. Athletes, you see, right? Tracks, running track. Same like that. These are tracks actually, but these tracks again divided like this, partition kind of thing. Correct? The smallest unit here is called as a sector. Smallest unit is the, so your data is written onto these sectors. Please keep it in mind. Right? You can zoom in, guys. Who are using the mobile or desktop even, might be right. You can zoom into this area. I hope you are able to do, correct? You can zoom in your laptop, in your mobile, you can zoom in. Online, guys, for you. Now, back to this. So we are talking about the smallest unit is a sector. So on your hard disk drives, HDD, hard disk drive, right? The smallest unit is your sector. So there is a size for sector. What is the sector size? It is 512 bytes. How much? The smallest unit of the hard disk on your hard disk is 512. Most of the hard disks what we have till now, they're all 512 bytes. The latest hard disks, they're coming with a 4 KB of sector, bigger sector. Correct? Okay. This is the smallest unit. Means whenever it is writing data or reading data, it will always read and write with 512 MB of size. What size? 512 MB of the size. Done? Now, on top of hard disk, who is accessing the hard disk? Your OS. Your operating system will access. OS is saying, boss, 512 is very small. No, it's not even 1 KB, 512 bytes. 512 plus 512, that's 1024, it will become 1 KB, kilobyte. Correct? It's not even 1 KB. Why? Because at the OS level, operating system level, in our system even, we have so many files. What files? Word, Excel, PDF, images, videos, so many. What are the sizes? They are mostly in MBs, 1 MB, 2 MB, 3 MB, 5 MB, or something like a 500 KB. Getting my point? Yes, they are in MBs or KBs, KBs or MBs. Most of the files. Very few files are there. They are in GBs, like a software or a movie, something. They are like a 1 GB, 2 GB, 3 GB, 4 GB. But most of the files are all in KBs or MBs. Now, when you are reading a file, how much data it will read in one shot? 512 bytes in one shot. Correct? If I want to read 1 KB or if I want to read 1 KB, how many IOs I have to do? 2 IOs? 1 KB. 100 KB means how many IOs? 200 IOs? Double, right? Yes or no? I'm talking about just 100 KB file. 200 times I have to read. Because in one shot I will read or write how much data? 512. OS says, sorry man, I don't want to go with your sector. It is a very small for me because my files are in really KBs, hundreds of KBs and MBs. I want to have my own. So what is that? That is called as block size. OS, they came with their own block size, a multiple of your hard sector. What is that? Generally, it used to be 1 KB, 2 KB, 4 KB, kind of thing. In olden days, older versions, we used to have 1, 2, but now the one is what? So what is this 4 KB is my what? Block size of what? OS. My OS block size operating system, the block size is 4 KB. Correct? Now, what is this block size 4 KB? Nothing but a group of 512, 512, 512. So like this 512, 512, 512, it is going to make it as 4 KB of block. That means whenever OS need to write or read, OS is going to send 4 KB of data in one shot, reading what? 4 KB of data in one shot. You can come here. Just little pull it back and you can use that. Careful. Done. Thank you. Got my point? Okay, so now this way by 4 KB, same 200 KB, sorry, 100 KB of file. 100 KB of file, how many IOs? By hard disk, 100 KB of file, we did 200 IOs, correct? With same 100 KB, if I am having 4 KB block size, what is the size? 4 KB, how many IOs? 25? Big difference? Yes or no? You are trying to reduce the number of IOs, man. The logic is here what at the end? Reduce the number of IOs. Faster, yes or no? Agree? Simple. Another example I'll give you. I want to prepare a tea. Normally we do all, right? We all do that. So I want to prepare tea at my home. How for family or for my personal, right? For myself, how much might be 1 spoon or 2 spoons sugar? 1 spoon sugar, 1%. 5 people, okay, 1, 2, 3, 4, 5. Done. Over. At family, that the way we do, right? We all mostly correct. If it is a small get-together gathering, all relatives are there. 30 people, 40 people, 50 people gathering, and you want to prepare a tea. Same spoon, 1, 2, 3, 4, 5, 50. Are you going to count that way? No, right? Painful. People, what they do, especially ladies are expert. Hey, boss, don't do with the spoon, right? Take a cup or a small glass kind of thing. Okay, 1, 2 glasses enough. Faster or not? If I go on doing 1, 2, 3, 4, 5, 50, it will take a lot of time. Reducing the time by increasing the capacity. The same way, instead of 512, OS decided to go with what block? 4 KB. Now, whenever I'm writing or reading, I will go with a 4 KB because my files are bigger, not smaller. Done? Understood? So that way the IO operations happen. But in Oracle database, on top of OS, we got what is that? Database. Database is saying, hey, my files are very big. You are saying most of your files are in KBs and MBs, OS, but my files are always in GBs. Very few are in MBs. Minimum 2 GB, 10 GB, 20 GB file, a single file. I'm talking about many files like that because database size example 1 terabyte, right? I can't go each file by 100 MB, 100 MB. No, not possible. I'll go with GBs only. Make sense, right? Yeah. So GBs, my files are in GBs, and whenever I want to do an IO, I don't want to depend with your block. So what I will do, I am coming with my own block size. So database is having their own block size, saying what? Okay, again in this you have options 2 KB, 4 KB, 8 KB, 16 KB, or another is what? 32 KB. The default is what here? It should be always greater than and multiple of your what? OS block. Simple. If OS is 4, you can't go with the 4 here. So you should simply skip that. So you have to be always higher. In older versions, very old version, man, we used to have OS block 1 KB. I seen the database block as 2 KB even, 4 KB even, older versions. Oracle 8i, 9i's, yeah. But as database is growing, the files are growing. Files are growing very huge. So now, as the files are bigger and bigger, Oracle came with their own bigger block. What is that? 8 KB is a default. By default, 8 KB. If you don't define anything, it will take what value? 8 KB. Got my point? No, if you want to have a different block other than 8, 16 or 32, then while creating your database, while database creation, you should specify what block size you wanted. Make sense? During database creation only, you need to select the block. If you don't select any block, by default, it will go with what? 8 KB size. Understood? So database block size is always multiple of your OS block. Multiple means if it is 4, I can go with 8 or 16 or 32 only. Correct? So by doing this way, you are reducing this IOs much more. 100 KB and this is 8 KB means how many? Hardly 12, 13. Understood now? So database size is again bigger block. Same like if you're having a party, a big party, celebration, 200 people. Do you want to go with a glass again? No, I prefer to go with a jug or a kg kind of thing, 1 kg, 1 kg kind of thing. Bigger or not? No way thinking about spoon. 500 people by spoon, no way. So that way you're reducing the time by increasing the capacity. Same thing the block is actually going to do. Keep it in mind, very important thing actually, right? But we always leave it to the default. We never think about the block. We leave it to the default as it is, right? Okay, same, we will do it here. My block size is, what is the block size now? 8 KB, 8 KB, 8 KB is the block. Clear? Shall I continue? Okay, now what I understood, this is my block. This is my block, right? In this block, I am going to write my data, right? Data is nothing but your row, right? Employee ID, employee name, job, salary, department, all the columns comes up here. Correct? This is called as what? A row. A row with all the columns. Yes or no? Right. What is the size of my block? 8 KB is the size of my block. And what is the size of the row? That depends on number of columns you have and the size of each column. Size of each column. While creating table, you will mention employee name, varchar 2 of 40, 50, 80, 100, number of 2, 5, 10, 20. Yes or no? Just like how many letters, characters you want to have in that. Correct? Size. So number of columns and size of each column will define what here now? Get my point? So if a row is having around 10 columns, each one with 10, 10, 10, 10, 10 kind of digits, what it may be letters. So total will be something 100. 100 letters you got, 10 into 10. Correct? 100 letters, let's say 100 KB or 100 bytes. 100 bytes, example. Just example. Correct? There are 40 columns, same 10, 10, 10, 10. It will become how much? 400. Big, more or not? The more the columns and the size of each column is called considered as a. Now for our example purpose, man, for our understanding, I'm saying here on an average. So like this, your rows are recorded in this block. Rows are saved, recorded in this block. What is the size of my block? Now my row size on an average, each row size on an average is 1 KB. My row size is, my block size is, how many rows I can fit in this now? Is that clear? Simple mathematics, guys, right? Follow me. 8 rows. Got it? Done. A block, the rows, the row size, many terminologies. Okay, now why we were talking about it, I'll come back to this part now next. So I'm going to say now here, my employee table. Now we are coming back to our query, right? Our main query. So what is that? my employee table from EMP. This is the query we find. Select few columns from employee where employee number 101. Now I'm telling you guys, in employee, there are how many rows? 100. How many rows are there in employee table? There are 100 rows. What is the size of my block? What is the size of my block? 8 KB, correct? Okay, this is my block, 8 KB block. Now for our better understanding, calculation, I am going to say you guys, in this block, we have around, in this calculation you understood, right? For our understanding, I'm telling you that, okay, in this block, we are able to fit totally how many rows? 10 rows. Okay. So in a block of 8 KB, on an average, we got how many rows? 10 rows. Now table contains totally how many rows? So how many blocks I need in that case? Calculate. In one block, I can accommodate 10 rows. So if my table is having 100 rows, how many blocks I need?
8 blocks. 8 blocks.
How many? In one block,
Sir,
I
8
can
blocks
have
you need.
10 rows. In one block, please, one block, I can have 10 rows. To accommodate 100 rows, how many blocks I need?
10.
8 blocks we need.
8 blocks into 10 rows. How much it will become, man? 8 blocks. In each block, how many rows? 10 rows, how much? 8 into 10. 80. What about the remaining 20 rows? How many total rows I have? So if I want to store 100 rows, how many blocks I need? 10 blocks.
10
Yes or
blocks.
no? 10 blocks into 10 rows each, total 100 rows. So 100 rows to store, we need 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Understood? Clear? Simple mathematics. That's why I told you guys. No tricks here. Right? No puzzle game. Simple. So each block for our bed, instead of taking 8, just forget about it. I just only for understanding about the block and rows and number of rows, I just made you understand. Now here, this is the main part. My block is of 8 KB, and in this one block, I'm able to fit 10 rows in 8 KB of block. Let me write here 8 KB of block. I'm able to fit 10 rows. To fit 100 rows, how many blocks I need? How many blocks I need? 10 blocks. 10 blocks I need. 100 rows, 10 blocks. Done. So all my 100 employees, 100 rows, 100 employees, they are stored, their information is stored in these 10 blocks. Understood till this point? Let me jump to this side. Okay. We got the files here. These are my data files. One of my data file here, which contains what are this? What are these? Yesterday we discussed. So this one is done, right? Shall I clean up this area? I'm just cleaning up this area, right? Row size and a block. Yesterday we discussed. What is this? Data dictionary tables are base tables which contains metadata. Done. Now we got here the another data file. In this, we will create all our tables. So my employee table is here. My employee table. Now my employee table having how many rows and how many blocks? 10 blocks. So you can see here we got 100 rows in these 10 blocks. Done. On the storage in your hard disk, there is a file. File consists of the blocks, right? So 8 KB each block, total 10 blocks, 100 rows are there. Right? Now come back to the query. Query still in the same place. Now let's look at the query. How many rows you are expecting from this query at the end? Where employee number equal to 101, employee ID or employee number 101. How many rows you are expecting in return?
One.
Only one, right? Employee ID 1. So now guys, anyone, can anyone tell me where is that 101 employee ID row could be? In which block? Anyone having any idea? We are trying to search, or you gave a query to the server process. The server process's job is to bring this employee number 101 record. Now, do any one of us, right, do we know that where is that 101 row stored in which
Sir,
block? Any idea?
11th block. 11th block.
11th block. Who is this? How many blocks you have, man, totally? We have 10 blocks. See again, okay. Don't think that employee IDs are starting with 1, 2, 3, 4, 5, 6 numbering. No, don't go with the number. I told only 100 rows. You might be thinking from that point, right? 1 to 10, 11 to 20, 30. No, not like that. Random numbers are there. One employee ID. Out of these 100 rows only, there is one employee ID with 101. Do you know where it is located in these 10 blocks? Out of this 10?
No, we
Even I
don't know.
don't know. Even I don't know. So even Oracle doesn't know that. So what happens in that case? It could be in any one of the blocks. So I have to search each block. So what Oracle will do here, please? What Oracle is doing? It is going to do an IO and bring these blocks into which area? What is this area? Buffer cache. It is doing an IO and bringing these blocks into the memory. How many IOs it will do now? One IO equal to one block. One IO equal to one block. So how many IOs it is going to do? Is that correct? It is going to do 10 IOs, loading all the 10 blocks into the memory buffer cache or cache. After that, it is going to scan each block to find that row 101. Yes or no? How many blocks it is going to scan now? How many? 10. Nearly 10? Yes. Let's count it as a 10. So what I am understanding, to get your record, it is going to do 10 IOs and 10 scans. 10 IOs, 10 scans, and finally it will get the record, right? And that one particular record it will select and return it to the user. Return it to the user. Now user process is going to display you on the screen, and now you see there is one record you received. Retrieving data, taking data from your block and returning it to the user, that operation is called as what? Fetch operation. That operation is called as a fetch. Okay. Understood this part? Okay. So as I don't know where is that row, that one particular row located in any of these blocks, I don't know, I'm not aware. What it did, it has simply taken the complete table, all the blocks into memory by doing the complete IO on the complete table, all the blocks, scan those blocks and fetch the records, correct? So what it did, it has performed an IO across all these blocks, right? And finally got the record, correct? So scanning the complete table is actually called as full table scan. Shortly, we call it as FTS event. But this scan is called as what? FTS or full table scan. Full table scan. This is the slowest scan in database. Correct? This will take the maximum time to get your data. No need to write, please. Close the books. Don't write. Close. Please close. Right? Don't write. This is the slowest way of getting data because it is taking the maximum time for you. How? By going through the table, bringing all the blocks, right? Scanning all the blocks, 10 IOs, 10 scans, and finally you got that one record for you. It's a time-taking process. Entire table, all the blocks got scanned here, called as what? Full table scan operation. Slowest one. As a DBA even, right? Many times our role will be, or not only ours, actually developers, because they are the one who are writing the queries. We are not writing any queries. Developers basically they write the queries. They are the one who are designing the application, coding, writing queries. They all do. Our job is to just provide the database for them, right? So we need to monitor even, our developers even need to monitor that the queries, are they going through full table scan? That means it will take the maximum time for their queries. That's because it is a slowest method. Reading the entire table from the disk. Disk is nothing but on the storage, right? Reading from a file from your disk, which is the slowest unit. Hard disk is very, very, very slow, man. Correct?